This is a question from P3 Additional Science. Okay, so this question is about speed and acceleration. Look at the diagram. It shows the two runways at Manchester Airport. A road passes through tunnels underneath the runways. Okay, so this might sound a little bit confusing at first, but if you look at the picture they provide, that should help you. The tunnels are of equal length. So let's just look at the picture. We've got the road, tunnel X, which goes underneath runway 1, and then tunnel Y, which goes underneath runway 2. So these are the two runways, and if you picture you're in a car, then the car is going to travel under both runways. Okay, let's have a look at the data they give us. Look at the information Katie collects about five cars passing through tunnel X and then through tunnel Y. Okay, so we've got our cars A, B, C, D and E. We've got our time taken to travel through tunnel X and time taken to travel through tunnel Y. Okay, so it's 20 seconds to go through tunnel X and then 22 seconds to go through tunnel Y. Okay, so it takes longer to go through tunnel Y. If you look, the next one, car B, 25 seconds and then 24. So for car B, it's actually taking less time to go through tunnel Y than it did tunnel X. It's faster by 1 second. Okay. So in the tunnels, each car travels at steady speed. Between the tunnels, the cars change speed uniformly. So they might accelerate or they might decelerate, okay? And you can tell that by whether they are taking longer or shorter time to go through the second tunnel. Which car decelerates the most between tunnel X and tunnel Y? Okay, choose from A, B, C, D and E. Now let's just have a look at our times. We're looking for it taking longer to go through tunnel Y than tunnel X. That will mean that it's decelerated and it's going slower. Okay, so we're looking for a longer time in tunnel Y. So car A, 20 seconds in tunnel X, 22 in tunnel Y. So that's a contender. B, 25 in tunnel X and 24 in tunnel Y. So that one's got faster, so we can't choose that one. Number C, car C, 27 and 27. So that's the same time through both. So that's not accelerated or decelerated. Car D, 27 and then 21. So that car's sped up. And then finally car E, 23 and then 26 through the second tunnel. Now if you look at the time difference for car E, that's taking 3 seconds slower, whereas car A is only 2 seconds slower. So car E is the one that has slowed down the most. Okay, we'll put our answer in there, car E. Let's move on to part B now. Car A is travelling at 30 metres per second through tunnel X. Calculate the length of tunnel X. And the equations on page 2 may help you, and I'm not going to show you page 2, I'll just tell you the equations that you need. Okay, so we're looking at speed equals distance over time. We can rearrange that to for distance. So distance equals speed times time. Now let's put in our values. That's 30 times 20 equals our distance equals 600. Now I got the 30 from here, and I got the 20 from this table down here, okay, because we're talking about tunnel X and we're talking about car A. So multiply those two together, we get 600 and put the answer in the space provided. Okay, part C. Katie buys a new car. It has a mass of 900 kilograms. The car can accelerate from 0 to 20 in 4 seconds. Calculate the accelerating force. And again, we've got our equations on page 2. Now I'm going to get the equation you need. It's acceleration equals change in speed over time. Okay, so we've got our acceleration as 20 divided by 4, okay, because it's the change in speed, it goes from 0 to 20, so that's a change of 20. We're dividing it by a time, that's 4 seconds. So the answer comes out with our acceleration as 5 meters per second squared. Now it's asked us for the force, and we're going to use Newton's second law, and it's already listed there. Force equals mass times acceleration, that's Newton's second law. So let's put our numbers in. Force equals mass, that's mass of the car at 900, and acceleration, we previously calculated that to be 5, so our answer is 4,500 newtons. Okay, now the last question here, part D. Look at the graph and show how the speed of Katie's car changes with time. Okay, so we've got a lovely graph here, speed, time, speed on the y-axis, time on the x-axis. The question they're asking is, how can you use the graph to find the distance travelled for the first 4 seconds? Okay, now this is something you need to remember. If we've got a speed time graph, not a distance time graph, but a speed time graph, the distance travelled is equal to the area under the line or the curve if you've got a curve. So it's the area under the line. And in this case, we would be able to calculate it by multiplying the time, which is 4 seconds, times by the speed change, which is 20 seconds, and then we divide it by 2 because, of course, it is a triangle. It hasn't asked us to calculate it. It has said how would we find it out. So simply we can just answer calculate the area under the graph, and that would get you your 1 mark. Okay, thanks.